In this video, we're going to have our first look at Chapter 1, which is a review of real numbers. We're going to start with Section 1.1, which is about integers, opposites, and absolute values. So this is what we're going to do in this section of this video. The first thing I want to talk about are number sets. These are sets of numbers. Anytime I talk about a set in mathematics, all I'm talking about is what is a group or something that shares some characteristics. And more specifically, I'm going to talk about number sets. Now, one of the broadest number sets that we're going to talk about, or the broadest number sets that we're going to talk about, involves the real numbers. And these are basically any numbers that can be put on the number line. And remember, your number line is basically a straight line where you can put some numbers on it. You can, put some increments here, and any number that you can plot on your number line is going to be considered a real number. All right. For instance, if I wanted to plot the number 2, then I'll go to 2 on my number line and put a circle or a dot there, and that'll be the number 2. So 2 is a number line, and any number here that you can see or that you can think of is going to be a real number. I also want to talk about natural numbers, and basically natural numbers are your counting numbers. So once you start, first learning about numbers, what most people start at is at 1, right? So numbers like 1, 2, 3, 4. So ever since you were a little kid, you've basically been looking at your counting numbers, and so it'll continue indefinitely till you get to 100, a billion, a million, so on and so forth. So those are your counting numbers. Whole numbers are your counting numbers with 0, right? So instead of starting with your counting numbers, we're going to start with 0, and then we're going to put our counting numbers in there. And those are what we're calling your whole numbers. And so, again, they're going to continue indefinitely, but these are your whole numbers. Now, in order for us to develop knowledge of your other numbers, then we've got to do some other stuff, go over some definitions. Note here that I am using these squiggly brackets that I like to call them, squiggly brackets. That is what we call set notation. All right, where you put things into a set separated by a comma, that's what I'm calling set notation. So this is the set of natural numbers here, and this is the set of whole numbers here. All right. I want to talk about opposites because in order for us to get to our next type of number set, we got to know what an opposite is. And basically, when I drew that number line on the previous slide, notice that I started with 0. Well, there are actually numbers on the left-hand side of 0 versus just being on the right-hand side, and those numbers are your negative numbers. And so when I start talking about negative numbers, I get into what I call opposites. My definition of opposites are numbers that are equal distance from 0, right? So if I put 0 in the middle of a number line and I do some put some numbers on the left-hand side, then I'm going to start with my negative numbers, counting -1, -2, -3, so on and so forth. And notice that I have those arrows on each end of my number line, notating that my numbers will continue. And so if I want to find the opposite of certain numbers, all I have to do is make sure that those two numbers are the same distance from 0. For instance, let's look at this example A. I want to know the opposite of 3. Well, 3 is 1, 2, 3 units from 0, right? If I were to plot that, that's 3 units. And so if I want to know its opposite, all I have to do is go 3 units on the other side of 0, and I'll get to -3. Therefore, the opposite of 3 is -3, okay? Notice this is a positive 3, all right? So this is where our positive and negative stuff comes into play. And this opposite has the exact opposite sign, right? So if I want to know the opposite of -5, well, just do the opposite of a negative, which is a positive, and keep that same number. So it'll be +5. 0 is a neutral number. So if I want to know its opposite, well, since it's neutral, it doesn't have a sign. That's what I mean by neutral. And so 0 doesn't have an opposite, or if you want to call it an opposite, you just say that it's 0. All right? 0 is 0 units from itself, so 0 would be considered its opposite using this definition up here. All right? So with those opposites, now we have expanded our number line, and now we can talk about what we call integers. These are the whole numbers and their opposites. For instance, when I first started looking at whole numbers, I said we start at 0 and we count like our counting numbers, so on and so forth. Well, to do the opposites, notice 0 doesn't have an opposite, or 0 is an opposite, so I'm not going to write another 0 here, but I can do the opposite of 1, which is -1, the opposite of 2, which is -2, opposite of 3, which is -3, and I can continue here. I'm going to put some dots there to note that both sides will continue. And so these are our integers. The last two number sets are rational numbers and irrational numbers. Rational numbers are numbers that can be written as a fraction. For instance, all right, so pretty much with the integers, the whole numbers, and natural numbers, those are like wholes, all right, whole numbers, sort of, so to speak, and their opposites. But when we get to fractions, we get rational numbers, we get to fractions. That means we have parts of numbers, not the whole concept there. For instance, a rational number can be written as a fraction, and remember, a fraction represents a division of two numbers. And sometimes when we divide, we don't divide and have wholes each time. For instance, I can have a fraction 1 over 2. 1 divided by 2 is not a whole number. It's a fraction. It's a rational number. 2 divided by 3. 9 divided by 17. All of these are rational numbers. They can be written as a fraction. In addition to those numbers that we can see as a fraction, a number like 2 is also considered a rational number because I can write 2 as 2 over 1. And we'll talk more about whole numbers and writing them as fractions and stuff like that a little bit later. But any number that is either a whole number, an integer, or a fraction is considered a rational number. These would also include decimals. For instance, 3.4. Later in this chapter, we will talk about how we write decimals as fractions, and 3.4 is an example. Or I can have something like 0.3. That bar up there means that it's repeating. I can write that as a fraction as well. And so all of these numbers, and there are many, many more, will be considered your rational numbers. Last thing we're going to talk about, the last type of number set that we're going to talk about are irrational numbers. And basically, irrational numbers are numbers that can't be written as a fraction. And one of the most popular is pi, right? We use this symbol for pi. Of course, we do give an approximation of pi as 3.14. But that is an approximation. It is actually a decimal that does not terminate, meaning it's 3.14 blah, 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 blah. And if we wanted to say all the digits, we couldn't, or we'd be talking forever. All right. Pi is an example. We won't really use that in this course. We won't use irrational numbers too much in this course. I just want you to know that it is a number set. E is an irrational number. Square root of 2 is an irrational number. And there are so many more. All right. So with these are all the number sets that are a subset of our real numbers. And as you get further in math, you'll develop another set of numbers as well. Now that we know how to identify numbers, we know what I want to talk about now is inequalities. All right. Anytime we want to compare numbers or values, we can use what we call inequalities. And there's basically 4 symbols that we use when we want to use inequalities. My first symbol is here, right? I have this sign here. It looks like a sideways V. Notice it's opening to the left. This sign here means greater than. And I just spelled that incorrectly. Greater than. And if I put a little bar under that, that notates greater than or equal to. Okay? When my V is opening to the right, it represents less than. And if I put a bar under that, it'll be less than or equal to. And so these are the things that we're going to use in order to compare two numbers. All right? And these are some examples. I'm going to use my less than or greater than symbol in order to compare two numbers. All right. So 3 and -10. Well, we know that since 3 is to the right on the number line, so if we were to draw a number line, and I'm not going to draw a detailed number line, but +3 would be over here and -10 would be over here. Notice that 3 is to the right on my number line. And so that means that it is greater than. So instead of using the words greater than, I'm going to use the symbol, which means that sideways V that opens towards the 3. All right. If I compare -8 and -3, It's a little bit harder for a couple of people to see, but negative 3 will be on the left over here, on the right, and negative 8, right? Because remember, 0 is over here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And so since negative 3 is to the right, notice this starts with negative 8, so negative 8 is to the left. That means it's less than negative 3. All right? And so comparing those inequalities, negative 8 is less than negative 3. Instead of writing the word less than, we're going to put the symbol that notates less than. All right? The last thing we want to talk about in this video is what we call absolute value. All right? And my definition of an absolute value is a number's distance from 0. All right? How many units is that number from 0? And the symbol that we use is these double bars here. So I put a number and I have double bars on the outside of the numbers. All right? We have 3 examples here. It says part A, find the absolute value of 5, right? And so probably won't need to actually draw a number line, but I will do it in this example. All right. When I want to find the absolute value of 5, all I'm doing is looking for the distance that number is from 0. And if you count, that is 5 units. And so the absolute value of 5 is going to be 5. All right. I can do the same thing for negative 8. I'll do it for this example as well. And again, I'm drawing a very quick number line here. I almost didn't make it, but if you count 1, 2, 3, 4, 5, 6, 7, 8, this is 8 units from 0, and so the absolute value of negative 8 is 8. Now, what a lot of people try to memorize is that, oh, when I see the absolute value sign, then all I do is keep the number, right? So absolute value of 5 is 5. Absolute value of negative 8, oh, I don't worry about that negative, it's going to be 8. But you got to be careful here. Notice in this example that I have a negative on the outside of the absolute value. Well, the absolute value of 3 is 3 since it's 3 units from 0, but if I want to do the opposite of that, then I have to have a negative 3 instead of a positive 3. And that is how we find the absolute value, and this concludes our video.